Now let's speak about momentum conservation. Well, that's my shorthand writing. Get used to that. Momentum, dmu. We know mu is linear momentum. This thing is d dt cv rho u dv according to RTT, right? Cs u rho ur and ds equals sigma f. Sigma f is what? It's just the net force acting on our system, right? So basically this dmu dt equals sigma f is just Newton's second law, right? Okay, so now we want to transform this equation in an integral form into a differential form. How can we do that? Obviously, we need to combine these two parts, right? And we also want to represent the sigma f in other ways. Okay, so how can we transform this thing to combine it with this thing? We use the divergence theorem again. So first we consider this. U rho ur and ds. This thing is equal to the divergence of the things inside, right? Cv, the divergence of this thing, rho uu. So here we see the importance that we don't write a dot here, right? That's just a small reminder, okay? So here we have the divergence of a second order tensor, right? So we expect in the final result of this thing will be what? Will be a first order tensor, which is a vector. Okay. If written in the index notation, that is the notation using Einstein's summation convention, right? It can be written as something like this. We will save the charade of the dot product, delta ij something, okay? So the final result will be something like this, rho ui uj. The ui and uj, the two indices here, they cannot be the same, right? If they were the same, then we would get a divergence inside, right? But here, we want to take divergence. So to be a consequentialist, we can say that the index here has to be the same as some index inside, right? Let's call, so let's just represent the first u to have the same index as the d over dxi. So we'll get something like this. Okay, so this is this part. So how can we represent the sigma f? The sigma f. Well, the sigma f can be divided into two parts. First part is called body force. The other is surface force. Body force. Among body force, the most important and the most common one is the gravity. Okay, but now let's just write it as this way. If the body force is just gravity, then the F here can be represented as the gravity acceleration g, dv. This is called the body force. Also, the surface force. Obviously, the surface force acts on the surfaces, right? So we combine all the surface force. We see how this will, well, what this will give us. Surface force. Okay, so this thing we just copy it. Cv rho f dv. But this thing, the surface force, we know how we can represent it, right? By what? By the stress tensor, right? What are the stresses? The stresses are basically the surface force. The surface forces acting on different sides of our fluids, fluid cube, right? So actually, the surface force can be represented as what? As the stress tensor, right? And we pick out the right direction, so it will give us something like this: n times sigma ds. Okay, so now we can use divergence theorem to make this to be of a triple integral. So this will give us CV rho f, and here we have this thing, right? The divergence of sigma dv. So if written in the index notation, we can write it as CV rho fj plus ddxi sigma ij dv. This is the final result. You are welcome to check that this is indeed the result we will get.